Properties of exponents. We're going to, the first property we're going to talk about is called the product of powers. What does product say to you? When you hear the word product in this math classroom, what does that tell you, Josh? Multiplication. That's the answer we should get when we do a multiplication problem, okay? And then it says of powers. What is a power?
Like that's,
Isaac?
like that's like what you're, like, if like it's 4, you're taking the number times 4, like the number times itself 4 times.
Okay, if it's 4 to the 4th power, that would mean we're taking 4 times itself 4 times. So 4 times 4 times 4 times 4. 4 to the 4th power is considered a power. Okay, that number would be considered a power. Okay, so how would we actually take 5 to the 3rd power times 5 to the 2nd power without a calculator? What would we really actually do? Okay, Isaac?
Take the 5 times 5 to get 25, and take the power, extend the power to get 6.
Take the 5 times the 5 to get 25, and then what? I didn't quite follow after that.
And then take then multiply the powers.
I'm still not really following, but maybe what you're saying is what we're going to do. Okay, Brighton?
So 5 to the 2nd is 25, and 5 to the 3rd is 75. If you could times those two together, or add the two powers together and take the 1 by itself.
Okay, but I have to disagree with one thing that you might have said in there, that 5 to the 3rd power is 75. So, Malcolm?
Don't you just multiply the 5 and the 3 and the 2 and the 5 and just multiply the big ones?
So can we take 5 times 3 and get 15, do you mean? And then 5 times 2 and get 10? We wish you could, but no, we can't. Trey?
Write it out.
Write it out. What does 5 to the 3rd power mean?
125.
No, what does 5 to the 3rd power mean? I didn't ask what it's equal to, I said, what does it mean? Okay, so the 5 to the 3rd power means 5 times 5 times 5. And let's just put that in parentheses to show that's our 5 to the 3rd power. 5 to the 3rd power really means 5 times 5 times 5. And then we have our multiplication dot in between the two powers. And 5 to the 2nd power means 5 times 5. Okay? Now, right now, I really don't care what 5 times 5 times 5 is. I don't really care what 5 times 5 is. Here's what I care about. How many times did I use 5 as a factor? 5 times. So what we really end up with is 5 to the 5th power. We don't even care what that is right now, okay? We're trying to figure out some shortcuts that we can use, some properties that we can use, okay? I don't want our calculators involved here at all. Okay, 3 to the 4th times 3. How could we write that out? How can we write that out? Hand this so I can call on you, please. Malcolm?
3 times 3 times 3.
Okay, so for the first one you said 3 times 3 times 3
Times 3.
times 3 again, because we need 4 factors of 3, and then times 3, we only need 1 of them this time, because when there's not a power, when there's not an exponent up there, what do you suppose is the invisible number that really is there? 1. It's just saying, it's me, myself, and I. Number 1. So, I don't really care what 3 times 3 times 3 times 3 is. I want to know what's the shortcut way we could write this now. JC? 3 to the 5th. Okay. What does a to the 5th mean? Trey?
I don't know.
A times?
A times 5 times 5. A times 5 plus A times 5 plus
No. Look at what we just did up there. Come on, follow that. Kind of like the pattern that's going on there.
It's A times
A times A times A times A times A. In other words, take A times itself. It should be involved how many times? 5, right? So we write it out 5 factors of A we write out. And then times, put our multiplication sign between the two powers. And then A squared means, class?
A times
Okay, I got some unengaged people in here right now. Not liking it. So what's the shortcut way I could write this now? A to the seventh. I have 7. 1, 2, 3, 4, 5, 6, 7 factors of A. So A to the seventh it can become. Okay, how about 4 squared times 3 to the fifth? Isaac, what does 4 squared mean?
4 times 4,
4 times 4
then times
times
3 times 3 times 3 times 3 times 3.
Okay. So is there a shortcut way to write that one?
No,
Why not?
because they're two different variables.
We got 2 different things that are the factors here. We got 4s and we got 3s. They're not the same thing. So you know what? We're just going back to the way it was. 4 squared times 3 to the fifth. That's as good as that one gets. We cannot simplify that anymore. We can't shortcut that one. Okay, so study those for a moment. A, B, and C in particular, and tell me what conclusion do you think we can make then to fill in the blank here? If the powers have the same base. I want everybody to come up with their own answer, before I'm going to call it anyway. What do you think we could fill in the base of the blank with? Everybody's hand up once you have a word in the blank, whether it's in your head or actually written down. Okay, Josh, what do you think we should fill in the blank with? Add. Yeah. If the powers have the same base, or in other words, it's the same thing that keeps getting multiplied by itself, if they have the same base, add the exponents, keep the base. Because notice, what is 3 plus 2?
5.
5, and that's what we got, didn't we? And we kept the base of 5, didn't we? 4 plus, remember we said this is an invisible 1. 4 plus 1 is 5. And that's what we got. And we kept the base 3. 5 plus 2, 7, and that's what we got. And we kept the base A. But here we couldn't do it because why again?
Because there's factors and factors.
And what's that called? They don't have the same. No, they don't have the same. We now know the name for it.
Factors.
No, they don't have B.
Base.
Yeah, they don't have the same base. They have to have the same base to use this shortcut. 4 is not the same base as 3. You didn't know what that word was before, but now we do. So they don't have the same base. Okay. So let's practice. Here's how you're going to show work, and you have to show work. I already know. I already know what I'm going to hear on Monday, and I'm pretty sure Mrs. Crepson knows what she's going to hear too. I did it in my head. Because I have such an amazing head, and that's wonderful. But I can't start to dig everything out of your guys' heads. So you're going to show me on paper where I can use my eyes to see it, okay? So, first thing we have to do when we start a problem is we have to say, do they have the same base?
Yes.
Okay? Our base is 4. So we're going to write it down. Our shortcut is to do what? We don't want to have to write out all those multiplying like we just did. How are we going to shortcut this, Isaac?
Have to add the exponents.
So 2 plus
4.
4. And put them up there like exponents. Put them up there raised. Don't put them beside it and make it look like a multiplication problem. That's in that little exponent spot. It's raised. It's superscripted, it would be called on the computer. Okay? And so this becomes what? 4 to the 6th power. Do you think right now I even care what 4 to the 6th power is? No, we're not using calculators. We don't care. We don't care what 4 to the 6th power is. We're just coming up with a shorter way to write it. So that's what I have to see. Anybody want to arm wrestle over that? Malcolm does? I win Malcolm. So strong. At my age. Okay. Okay, number 2. Notice something. First of all, do they have the same base?
Yes.
What is that base?
8.
3.
Number 2, it's -3, isn't it? And notice something about that -3 that isn't true in number 1. What's true? What's different about the base this time? It's in what? Not quotations. Parentheses. And it has to be in parentheses. When the base is negative, you have to put parentheses around that base. When that, hear me on this because I'm going to mark it wrong on assessments. When that base is negative, it has to be in parentheses. So we're going to put our common base, which is -3, and superscripted, we're going to do what? What's going to be up in the exponent there? What's our work going to show? Malcolm?
2+1.
Just trying to bring you back to me. Did you hear what I said?
What's the exponent?
No, what are we going to do in the work? Shamarki?
2+1.
2 plus 1. Yeah, what's the exponent going to be, which is the work? Okay, and that's the work we're going to show, and then we're going to say that is -3, and we don't lose the parentheses. They're still there because the base is negative, and 2 plus 1 is
3.
3. It's -3 to the third power. Okay? Okay, why don't you try showing work for the next one on your own then? Show what you think I'm going to insist on seeing. Okay. Somebody that hasn't offered up an answer yet today. Offer up what you did. Cameron?
A1
To the
to the 1 power
1 plus,
7.
yeah, that's how we'd say it. A to the 1 plus 7 power. And that equals what, Cameron?
8.
A to the
A to the 8.
A to the 8. We're going to learn how to say this properly, okay? Don't say to me A8. A to the 8th power. Okay? Everybody get that? What happened? Okay. Well, what if there's three factors? What if there's 3 multiplications? Is that a big deal? What do you think? Is that a big deal, Ariel? No. Because they still have the same base, don't they? They all have a base of n. So what are we going to have added in the exponent now? 5 plus 2 plus 3. We just have a little bit longer addition problem there. So it's n to the
11.
10.
n to the 10th power. Okay, so now that we have this figured out, now let's make it trickier, okay? We now have a -3x cubed times 5x squared. Anybody know what that really means? Rose, what do you think it means? Oh, you have a question instead. Okay, what's your question? I don't know. That's a good question. Should it be, why did I just said if you're taking a base that's negative to a power, why it has to be in parentheses? So that's why I'm asking if we know what this means. So what do you think? Brighton, what do you think?
It means that x is with the -3.
You think so? In other words, the base is -3x? Is that what this means? Cameron?
The x is the one with the power.
The x is the one with the power, not the -3. Okay?
So x would be the base.
So here's what we're going to do first. Then it'll make it less confusing for us because they are going to these get tricky throughout this. So we're going to say, you know what, there's an invisible multiplication dot between that -3 and that x cubed. And then there is that visible multiplication dot. And then there's 5 times x squared, so there's another invisible multiplication dot there. So we're just going to insert those invisible multiplication dots because now we can see that, you know what, -3 is just a factor, but it's not being taken to a power. It's a constant right now. So here's what we're going to do. There's a property called commutative property of multiplication. Have you ever heard that in this classroom? You better have. What does commutative property of multiplication allow us to do? Commute. 3 times 5 is the same as 5 times 3. Commutative property says we can what?
Switch places.
Switch places, multiply in any order you want. So we're going to have things So here's what we're gonna do. We're gonna let the -3 get multiplied by the 5. So the 5 and the x cubed are gonna switch places. We're gonna put the guys that have the same base beside each other. We're gonna put those same bases beside each other. And these are constants. -3 is a constant, 5 is a constant. We really could write them as powers, but we don't need to. Now we are gonna multiply those guys. What is -3 times 5?
-15.
-15 times x to the, now we gotta show our work here, x to the, JC? 3 plus 2 power. And so now we're gonna say that our answer is, Ariel? So we can leave our times out. It's gonna be -15. We probably better box or circle that because we got a lot going on there. -15 x to the 5th power. Okay, this is where we're getting into tricky stuff. I gotta make sure that you understand how to do this before we move on. Anybody have questions about that? Okay, then let's go on to number 6. What do you think is the first thing I'm going to suggest we do in this one? The first thing I suggest that we're going to do. Any ideas? Seth, do you have an idea for me? What would be the first thing I'd want to do in this problem? Yeah, put the multiplication dots in. There's some invisible ones there, aren't there? There's an invisible one between what?
M in the end.
M and the n here, m and the n cubed. Then that one's visible. Is there some more invisible ones?
Yeah. 2 times m to the 4th power.
Times n squared, right? So in other words, we just want everything to have its own little spot with multiplication dots around it. Okay, what order do you suppose we should rearrange this in? Let me remind you what algebra likes. It likes the constants first, and then it likes alphabetical order for some crazy reason. So what do you think we should, how should this get rearranged? And you're going to show me rearranging it. Okay? So, Isaac, what do you want me to do?
Take the 2
The 2 comes out front.
times, and then put the m's together.
Put the m's together. So m and times m to the 4th.
Then times n cubed
Cubed or
times,
to the 3rd. Times
n squared.
squared or n to the 2nd. So now we have, this is the order they like. Constants in front, alphabetical order after that. So does that 2 have anything else to be multiplied by?
No.
No. So it's going to be 2. And then we're going to have times m to the what power? What's our work going to show?
4 plus 1.
1 plus 4. We'll do it in the order we have it, okay? Because there's an invisible 1 on that one. Times n to the, what's the work going to be for that one?
3 plus 2.
3 plus 2. Okay. And now we're ready to come up with an answer, aren't we? And we've ditched the multiplication dots in between. 2 doesn't have anything to be multiplied by. It's going to be m to the what power, class? 5th power. Thank you, Isaac. That is the class. Isaac isn't the class. You guys are part of it too. And n to the 5th. Okay. There's our final answer. Okay, now that you're so good at this, you try that last one here on this side on your own. See if we all get the same answer. make a little suggestion for you before you move on. After you've done your rearrange step, count to make sure you have them all, so you don't forget any of them. So in other words, after I've inserted my multiplication dots, I count and I see I have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9. I didn't leave any of them out. And when you're all done, you can look up and see if you agree with me. Because I'm going to claim to be right.
I'll agree with you.
So when I wrote in black, I was inserting multiplication dots. When I wrote in blue, I was rearranging. When I wrote in green, I was showing my work using my product of powers property. And red is the final answer. So when we multiply powers and they have the same base, we can do what with their exponents? Add their exponents. That's the property we need to remember there. Yes, Brett?
Like, I kept the multiplication points between, like, I think 20 and x plus, or x in the third power and 5 in the second.
Yeah, it wouldn't be wrong, but you just wouldn't see it in an answer bank like that. They would get rid of those because you don't really need them there. And
So I could keep it like that.
well, you can, but I want you to start getting used to cleaning it up. In other words, we would want to go one step further and just clean it up and not have the multiplication dot there, okay? Okay, but I couldn't count yours wrong, no. But in an answer bank, that multiplication dot would not be there. Okay, anybody else? Okay, because we're gonna learn a new property now. So you got this one down? Maybe. Okay, well, let's go try. Power of a power property. In other words, here's the deal. We know what a power is now. It's a base being raised with an exponent. That's a power. And when we take a power to a power, that means there's going to be another exponent up. So in other words, we have to multiply that times itself, however many times that other exponent is. So 3 squared to the third power really means, first of all, what? It means, Isaac?
Well, I was going to say 3 to the 6th power.
Okay, but we got to figure out for sure how we get there. What is 3 squared to the third power? So we got a power, 3 squared, being raised to the third power, so we got a power to a power. What does that really mean, that problem, Ariel?
3 times 3.
How about can we just start like this? It means 3 squared times 3 squared gets multiplied by itself 3 times. This means this, you guys. We got to know what that means. 3 squared is being used as a factor 3 times. That's what that means. Okay, and then we know that after now we have a product of a power. Now we get a multiplication problem that has powers in it. What do we do when they all have the same base? Add their exponents. So now we're going to say, oh, well, then that can be written like this. 3 to the 2 plus 2 plus 2. They're all squared. And that equals 6. 3 to the 6th. Okay, what does x to the 4th squared really mean? What does it really, really mean? Okay, I need some, come on. Come on, I need some new hands. Thank you, Malcolm.
X to the 4th 2 times.
x to the fourth 2 times. So x to the fourth times x to the fourth. X, that's what the base is. It's being squared. Now we got rid of the power to a power. Now it's a product of powers. And what do we do when we have a product of powers and they have the same base? Cameron? What's our base?
X.
X. And we are going to do 4 plus 4. Yeah. You know, maybe what's confusing for some of you at this point is those parentheses here. It would be okay if you did not show these parentheses, if that makes more sense to you. Does that make more sense? That we're taking x to the fourth times itself? Does that help to get rid of those parentheses? Because then we can see, you know what? We have the same base. Our base is x. And we have to add its exponents. Maybe that's a better way to show that. Now what are we going to say our final answer is then? X to the 8. Okay. So what shortcut do you think we can take this time instead of having to show that all the time? Trey?
Just multiply 4 by.
So,
Well, on the brackets of number 8, just multiply 4 by 3.
so when taking a power to a power,
Multiply.
multiply the exponents. Yeah, just take those two exponents and multiply them. Because that's, if we would have done that, 2 times 3 is 6, and that's what we got.
That's why I said 3 to the 6.
I know you did, but we wanted to make sure that it, how does it get there, okay? And 4 times 2 is 8, like we got, okay? Okay, so now let's practice that. How are we going to show work for this? Again, I don't care what the final answer is, I want it just, you know, like you apply the property to it. So Cameron, what are we going to show for work?
4 to the 4th power times 3.
Okay, 4 to the 4 times 3 power. Yeah, that's how we're going to say that. 4 to the 4 times 3 power, which becomes 4 to the 12. Yeah, yeah, I don't care what 4 to the 12th is. Go parent it a bit. Okay, look at number 9. It's a negative number being taken to a power, so that's why it's in parentheses. And then we had to put I had to put brackets around it. I had to put another like type of parentheses because I'm gonna take a power to a power. So what should I show for work in this one? And what do I have to make sure I show with it this time? Brighton?
We'll take -3 to the 5th power times
Do
twice
this.
and have the parentheses and brackets.
Okay, but we're taking the shortcut, remember? So -3 has to be in parentheses because it's the base. And what do we do?
Multiply the exponents.
5 times 2, right? Okay, that's what you were trying to say to me? Okay, so it becomes -3 in parentheses to the 10th power. You have to have those parentheses there. You have to have those parentheses there. Let me say that one more time. You have to have those parentheses there. JC?
So why do you have the brackets?
It's because it's like a, notice how I had to use parentheses here? Notice these parentheses because I'm taking a power to a power. That's why those parentheses are there. So
Oh,
this,
now you're taking it to another.
yeah, this is like another set of parentheses, okay? Another question?
Yeah.
Okay. Isaac, what's your question?
Because that, the second, because the brackets around the -3 to the 5th power, that kind of confused me. So like, why, so.
Okay, so you know what we can do? They could be written like this too. So maybe this would be less confusing to you. A bigger set of parentheses with another set of parentheses inside of it. So this is the power, -3 to the 5th power, and that is being taken to the 2nd power. So the first set of parentheses is because it's a negative number being taken to a power. The second set of parentheses is because it's a power being taken to a power. That's why. Is that what your kind of question was to, Pamela?
Mine was why the exponent can't be with the negative. It has to be outside the parentheses.
Because otherwise, if it was inside the parenthesis, it would only be 3 being taken to that power, and the negative sign would not be part of it. And there's a difference, okay? In most cases. Okay. Any others, concerns? Okay, let's try the last one then. What's our base? X. What's our work? 4 times 5. It's a power. To a power, we multiply, and that becomes x to the 20th. Okay. Whew. Takes a while to get through all this stuff. Okay. We're going to skip over this part for right now, and I'm going to give you the last property, what the shortcut is. Power of a product. So in other words, here's what's going on. There's multiplication going on inside the parentheses here. Everybody knows that's the product. There's a multiplication going on inside the parentheses. That product is being taken to a power. Here, there's multiplication, 3 times x times y, being taken to the power of 3, a product to a power. When you're taking a product to a power, you're going to take each factor, or in other words, each piece that's being multiplied to that power. So every factor is going to get that power. So in this one, here's how we would show our work. We have 7 times a. So they each, 7 gets a power of 2, and a gets a power of 2. They each get their own exponent. We can do 7 squared. What is that?
49.
49. 49 and a squared. There's our answer for that one. Because it really means 7a times 7a. And 7 times 7 is 49, and a times a is a squared. Okay, so now let's do this next one. We have x to the 4th. That's a power, isn't it? X to the 4th is a power. So we're going to have to put that in parentheses because it's got to get its own power of 2. And then we have y to the 3rd. That has to get parenthesized because it gets its own power of 2. And then we got that times z, so now z has to get that power of 2. And the z is really not as important that we put the parentheses there because we don't have a power showing. What power is z being taken to? 1. So we really could stick a 1 there. Okay. What do we do here? We say x to the what?
4 plus
4. No, power to a power. What do we do with them? Times. 4 times 2 times y to the 3 times 2 times z to the
1 times 2.
1 times 2. So this is going to become x to the, no, 4 times 2 is not 6, 8. Y to the 6th. And z to the
2.
2nd. Yeah, 1 times 2. There's our answer. Okay. I know. That's how much fun this stuff is. Okay, but I did shorten your worksheet, what you had to do on it, so that should help. You have 15 problems to do. Some are going to go a lot faster than others. Some of them are going to be, some of these were on here, didn't take as much work at all. You want this? Do I want that? Oh yeah,